What if a virus could rewrite itself every hour just to avoid being caught? According to Google researchers, that's no longer hypothetical. They've discovered multiple AI-powered malware families that can actually change their own code in real time, making them significantly harder for antivirus tools to detect or analyze. Instead of behaving like traditional malware with fixed instructions, these new threats can adapt while they're already running inside a system. Google identified at least 3 of these AI-assisted malware families, including names like Prompt Flux, Prompt Steal, and Quiet Vault. What makes them dangerous is not just what they do, but how flexible they are. Unlike older malware that follows a predictable pattern, these strains can dynamically shift their behavior on the fly, essentially reinventing themselves during an attack. That means security tools that rely on known signatures can struggle to keep up. One of the clearest examples is Prompt Flux. This malware reportedly used AI to continuously rewrite its own code, in some cases regenerating its entire structure every hour. It would then hide itself in system startup locations to survive reboots and maintain persistence. Think of it like a criminal changing their face every few minutes, not to escape a camera once, but to stay unrecognizable indefinitely. That's the level of stealth being demonstrated here. Now let's take a closer look at the code. In Phase 1, AI-assisted obfuscation shows how the system begins by using a VB script to send prompts to the Gemini AI model, asking it to generate code snippets related to bypassing antivirus detection. This phase represents the entry point of AI involvement in the workflow, where natural language instructions are transformed into executable logic suggestions. On the right side, this is paired with the AI prompt block, which demonstrates how the system specifically engineers prompts to extract compact, functional VB script fragments. The emphasis here is on dynamic code generation, where obfuscation is not static but produced on demand through AI interaction, making behavior less predictable and harder to analyze using traditional static inspection methods. In Phase 2, the thinking robot module shows how the system repeatedly connects to the Gemini API using a built-in API key. This creates an automated loop where the script continuously asks the AI for new instructions or logic. The code section includes the call Gemini API function and the Gemini 1.5 model reference, showing how the system stays connected to the AI service. This phase focuses on automation, where the program's behavior can change over time based on responses generated by the AI. In Phase 3, metamorphic intent explores the idea of a program changing its own code over time. The commented out attempt to update self function suggests the developer may have planned for the script to modify itself using AI-generated responses. Even though this feature is disabled, it shows an experimental attempt to create software that can evolve and behave differently over time. This phase highlights the concept of adaptive code, where AI-generated output could potentially be fed back into the program to influence future behavior. In Phase 4, Static AV Evasion Goal describes the final idea behind the system, trying to avoid antivirus detection by constantly changing how its code behaves. Instead of relying on one specific function, this behavior comes from several parts working together, including AI-generated prompts, repeated execution, and possible self-modification. The logging system, like the thinking robot log, and the log file saves the AI outputs so they can be reviewed or improved later. Overall, this phase shows an experimental setup where the system changes its behavior over time, using variation itself as a way to avoid detection instead of using fixed or predictable patterns. The bigger picture is what makes this truly significant. Cybersecurity experts warn we're entering an AI arms race, where attackers use artificial intelligence not just to write scams, but to build malware that evolves mid-attack. This represents a shift in cybersecurity. Threats are no longer static. They are becoming adaptive, automated, and continuously evolving.